Welcome students. In this lecture we are going to discuss amines with particular reference to Gabriel synthesis, Hofmann degradation, Sandmeyer reaction. These are the contents. Firstly, we will see nomenclature and classification. After that, structure and stereochemistry of amines. Then preparations, method of preparation of amines, Gabriel synthesis, Hofmann degradation reaction, Sandmeyer reaction, and then basicity of amines. Let's start with the classification of amines. As you know, depending upon the number of alkyl groups attached to the nitrogen of the derivative of ammonia, there are specifically three types: primary amines, secondary amine, and tertiary amine. In the primary amine, the one of the hydrogen of the ammonia is replaced by methyl group. See here, in one of the hydrogen is replaced by methyl group and we get methylamine, that is primary amine. Here two hydrogens are replaced by methyl group, so it is a secondary amine. Its common name is dimethylamine. And here in this case, all the three hydrogen of ammonia are replaced by methyl group, that's why it is tertiary amine. Its common name is trimethylamine. Okay, so if we replace one hydrogen atom by alkyl group, it is primary amine. If we replace two hydrogen of the ammonia by alkyl group, it is secondary amine, and if we replace three hydrogens, then it is tertiary amine. Okay. Now see in the detail about this classification. These are the examples of primary amine: CH3, CH2, NH2, that is ethylamine; CH3, NH2, that is methylamine, and this is aniline. The first two are the aliphatic amines, and this is the example of aromatic amine. Now secondary amine examples, it is a dimethylamine because two methyl groups are there. Here one methyl and one ethyl group is there, that's why it is ethylmethylamine. I am talking about the common nomenclature only. And here the two hydrogens of ammonia are replaced by two phenyl groups, that's why it is diphenylamine. Similarly, tertiary amine, here two examples are given. This is trimethylamine because all the three hydrogens of ammonia are replaced by methyl group, and this is triphenylamine because three hydrogens of ammonia are replaced by phenyl groups. Okay, so primary amine, secondary amine, tertiary amine. Now, as I told you that depending upon the alkyl groups or aryl group attached to the nitrogen, there are aliphatic amines or aromatic amines. These are the classes of amines. Similarly, mixed amines may be there. Okay, as I told you, this is a aliphatic amine because these groups are aliphatic alkyl groups, and here it is a aromatic amine. Okay, because aromatic ring is there, that is phenyl ring is there. Okay. Now see the nomenclature. There are two methods of nomenclature, as you know, common nomenclature and IUPAC nomenclature. In IUPAC nomenclature, let me tell you how to write the nomenclature. You have to treat this as a derivative of alkane, and you have to give the nomenclature as an alkanamine. Let us see by taking the example. CH3NH2, methylamine. Now see here, methyl group is there, one carbon, so it is the derivative of methane. While writing the nomenclature, IUPAC nomenclature, you have to replace E of alkane by word amine. So, as here it is the derivative of methane, it is methanamine. Replace E of methane by amine, methanamine. Sorry, here there should not be a space, it should be in continuation, methanamine. It is CH3, CH2, NH2. CH3, CH2, NH2. Its common name is ethylamine. While writing the IUPAC name, you have to treat it as a derivative of alkane. So, 2 carbon means ethane. Replace E of ethane by amine. So, it is ethanamine. There should not be the space between this ethane and amine. Remember, it is continuous word, ethanamine. It is CH3, CH2, CH2, NH2. What is its common name? Propylamine. And what is the IUPAC name? How many carbons are there? 3. So, it is propane. 3 carbon means propane. Replace E with amine. So, it is propanamine. Now, propane and onwards, the position of the amine group is also matters. So, what is the position of this NH2 group? It is on the first carbon. This is 1, 2, 3. So, NH2 group is present on carbon number 1. So, it is 1 propanamine. Okay. Now, here see, this is isopropylamine, because this group is isopropyl group, because NH2 group is attached to the second carbon, isopropylamine. What is the IUPAC name? 2-propanamine. As 3 carbons are there, definitely it is the derivative of propane. Now, replace E by amine, so it is propanamine. Now, NH2 group is present on which carbon? Second carbon. From this side 1, 2. From this side again 1, 2. So, on both the side, from both the side, it is on the second position. So, it is 2-propanamine to indicate the position of NH2 group. Okay. Now, this one, it is common name, its common name is dimethylamine. Dimethylamine, its IUPAC name is dimethanamine. Similarly, it is a trimethylamine, common name, and its IUPAC name is trimethanamine. Okay. Okay, this is about the classification and nomenclature of amines. This is the basic, these are the basic things. Now, let us move on our next topic, that is stereochemistry of amines. Okay. See, you know nitrogen in the amines, that is primary, secondary, tertiary, as well as in ammonia itself. It is attached either to 3 alkyl groups or hydrogen and alkyl group. Okay. Now, this is the example of tertiary alkylamine that I have chosen here. R1, R2, R3 are the alkyl groups. Okay. You can choose secondary or primary amine or even ammonia also. Okay. As nitrogen is trivalent, it is attached to 3 alkyl or 3 hydrogen atom. And one lone pair is there on the nitrogen, you know that. And this is the pyramidal shape structure of amines or ammonia. And if you see the angle between alkyl, nitrogen, alkyl, RNR, it is 108 degree. What is the hybridization state of nitrogen? It is sp3 hybridized. We can detect it by calculating, by counting these sigma bonds. How many sigma bonds are there? 3. And one lone pair is there. So, 3 plus 1, 4. So, it is sp3 hybridized, nitrogen is sp3 hybridized. Being sp3 hybridized and the bond angle should be 109 degree 28 minutes or roughly 109.5 degree, but due to this lone pair the bond angle is reduces to 108 degree, remember. Okay. Pyramidal shape. Now, see here this lone pair of electron it is not steady, it is flipping. Okay, this means the time required for this flipping, this inversion is very, very small. See here, this is the structure particular of secondary amine, ethyl methylamine. It is ethyl group, it is methyl, it is hydrogen, and this is the lone pair. Okay, and there is the inversion. Inversion means flipping. And see this structure after inversion, the position is methyl, ethyl, and this is hydrogen. There is the inversion of configuration. And this inversion of configuration is so fast, it is very rapid. The time required for this inversion is very, very small. So, very, very small. So, it is not possible to isolate the enantiomers. Means we cannot isolate that these two are the enantiomers. We know the definition of enantiomers. They are the mirror images of each other and non-superimposable. These two structures which are written over here are the enantiomers of each other, because they are mirror images. If I see this structure in the mirror, it will look like this. But the thing is that these two structures are non-isolable, means one cannot isolate that these two structure. Rapid inversion, rapid flipping takes place. Okay. From this, it is clear that optical isomers of amines cannot be isolable. Cannot be isolable. Okay. So, this is, if they, as they are not isolable, means the amines, particularly secondary and tertiary amines, these are optically inactive. Remember what I learned, what I discussed in the stereochemistry, that the inversion or flipping of the lone pair from one position to another position is too fast. That's why we cannot isolate the isomers, and hence this is optically inactive. Okay.